we are going to look at is postulates that deal with area, and then one theorem, which is how you find the area of a rectangle. So, first up, postulate 17, we're on page 423. We skipped chapter 10, we're in chapter 11. Postulate 17, the area of a square is the square length of a side. Bar, you need to quit tapping your foot. Now, a square is a rectangle. It is a parallelogram. It is a rhombus. It's a rectangle because it has 4 right angles. It is a parallelogram because it has opposite sides parallel. And it is a rhombus because all 4 sides are equal. So if a square has side length S, this is saying, then the area is going to be S times S, which is that side length squared. And we can talk about why this is the case. Let's give this square a side length of 3. So a side length of 3 means that if I have a measuring in feet, I can draw 3 1-foot strips. I can draw straight lines. And on going this direction, the same idea. Side length 3 means I could draw 3 1-foot strips. So, how many square feet are there going to be in this square?
Yeah.
A square foot is, in fact, a square that is 1 foot by 1 foot. And we can see that there's going to be 9 square feet in this square. So we have then the area is 3 feet times 3 feet, which is equal to 9 square feet. And you write that as feet with the exponent of 2, or you can write it as 9 square feet. It is 1 square yard. Which means if you have square yards, what do you have to divide by to get, or multiply by to get square feet? By 9. If you have square yards, you have to multiply by 9 to get square feet. Exactly. Our next postulate, postulate 18. If 2 figures are congruent, then they have the same area. Now, congruent means same size, same shape. So it makes sense to me. And a postulate is something that we take as fact either because it is obvious or because it is needed. And this makes sense to me. Congruent figures are going to have the same area because they are the same size and same shape. Our next postulate, postulate 19, is our area addition postulate. And what the area addition postulate says is, if you have an area of a region that is odd-shaped, we can divide it into pieces of area that we know how to find, and then add those pieces together. So in geometry terms, The area of a region is the sum of the areas of the non-overlapping parts. So an example would be, yes, not yet. We have a strange shaped figure, maybe a trapezoid. We might not know how to find the area of a trapezoid, but if we know how to find the area of a triangle, then we can find the area of triangle 1 and the area of triangle 2 and add them together to find the area of the trapezoid. Or, there's more than one way we could divide it. We might have a rectangle and a triangle, right? So, whatever way you choose to divide it, you can divide it, find the area of the two pieces, and then add it back together to find the area of the whole. Theorem 11.1 is area of a rectangle. The area of a rectangle, because it has right angles, is related to the area of a square. If you know that one dimension is 3 feet, we'll say, and this other dimension is 5 feet, then the question would be, since there's 5 strips of 1 foot each and there's 3 strips of 1 foot each, how many square feet? You multiply the two dimensions. Because it's at right angles, you can do that. So the area of a rectangle is the length, its length times its width.
The other one,
3 feet by 5 feet. So area is L times W. Now, we could call it base and height instead of length and width. So sometimes you'll see the formula area equals base times height, like that. How about perimeter of a rectangle? Perimeter is a distance around the rectangle. This length plus that length plus that length plus that length would be the perimeter of that rectangle. So perimeter is a distance around and that would be what you'd think about if you're buying fencing. I do. We still have an assignment because it's stuff that I think is review for you. Your perimeter, then, is 2 lengths plus 2 widths. Because there is your length twice. There is 5 feet twice, and then 3 feet twice. You're going to have 2 widths plus 2 lengths. Hey, that is your perimeter. How about perimeter of a square? Perimeter of a square, same thing, yes, but how many of the same length do you have? 4 of the same length. So the perimeter will be 4 times that side length. Okay, your assignment is on page 426. And I will give you multiple, 2 through 24 minutes of that. Remember, we're on page 426. Oh. 2 through 24 even.
Oh, dang it. That's good.
Okay. I do have call duty. Otherwise, I'd be able to give you 10 minutes here to work on this. So you guys may go to lunch. Ouch. Oh, please stop this.